Hi guys, welcome to another exciting video. Today we're going to continue with few more topics. In the last few videos we have seen something called as exception handling, right? We looked at something called as interfaces. We saw an example of how interface works in Java, right? And different types of exceptions we have in Java, how important exceptions are and how Java handles the exceptions is very important topic. We have talked about it in the last video. We are going to continue with few more topics in this third unit, guys. I will see you right on the other side. Alright, in today's video we're going to talk about some very important topics, guys. We're going to talk about something called as threads, right? We're going to see the difference between something called as process-based multitasking and thread-based multitasking. What is the difference between them? What is a thread, right? And then we're going to see what are the different states the thread will be in, and then finally we will end it with something called as thread priorities. Okay, so we'll start off with today's topic. First we will see something called as process-based multitasking, right? Now, usually you already know that you normally buy a computer or laptop which are normally nowadays multi-core processors, right? You have something called as i3, i5, i7, i9 and so on. So what do you mean by these processors? Basically what it means that there are multiple cores in a single processor. That means it's a multi-core multiprocessor or a multi-core processor. So nowadays you will have multiple processors and each processor will have multiple cores, right? So whenever you write programs, it has to take advantage of this concept of your hardware, right? So basically, why do we have this multi-core multiprocessors? The reason is so that you can run multiple programs at the same time, so that the execution time decreases and the performance increases, right? So this is the reason why Intel and so many other companies come up with these new technologies, so that you can make the performance good, right? The performance will be faster and the execution is very fast. So remember, your C and C++ did not take the advantage of this technology, right? So in Java, it has come up with something called as threads, right? Basically the processor is made with multiple cores. Each processor will have multiple cores in it, and each core can run a separate process. Okay, so we'll see first what process-based multitasking is. As you already know, multitasking is nothing but doing more than one task at the same time is called as multitasking, right? Usually, conventionally, in about 90s or so, we had a processor like Pentium 1, Pentium 2 processors, where at any given time one program or one process would run on that particular processor. The other programs would have to wait, right? So nowadays that is not there. Most of the processors have multiple cores. That means multiple programs can run parallelly at the same time. So when you talk about a process-based multitasking, we are talking about more than one process or a program. Now what do you mean by program? A program under execution is called as process, right? Program is nothing but whatever you have written. Basically the code that you write normally for your application is nothing but your program, right? So that program under execution on the processor is called as a process, right? So the complete program, if it runs on a processor, is called as a process, right? So that is what we're going to talk about now. So a process-based multitasking is nothing but a complete program being run on that particular processor. That is called as process, right? So if you are running multiple programs or multiple processes on the processor, right, then it is called as process-based multitasking. So we'll see what it exactly means, right? So the first point you can see, a process-based multitasking, two or more processes or programs can run concurrently or parallelly on that processor, right? That is called process-based multitasking. Second point, in the process-based multitasking, process or a program is the smallest unit. That means that the program, the complete program or the process is running on that particular processor. There is nothing smaller unit than a complete program, right? What it means in the next slide we will understand it a little better. Okay, third point, process-based multitasking requires more overhead. That means it requires more, space to run, more time to run, right? This is nothing but overhead. So it requires more amount of your whatever hardware you have, for example memory, right? The more amount of time in the CPU, all these things are required for you to run a complete program on the processor. So that is what the third point says. Fourth point is nothing but it requires its own address space. The complete program will require its own address space, right? So that is the fourth point, guys. Fifth point, a process communication. Remember, two programs can communicate with each other, or the two processes can communicate with each other. When they want to communicate with each other, it is expensive in the sense it requires time or overhead. There is more overhead. That is the reason, right? Normally they will not, nowadays they don't write process based multitasking programs. They will write something called as thread based multitasking programs. So we'll see that in the next slide. So the communication between multiple processes is very expensive. It takes more time. So remember, when it is doing the communication, there is a lot of time wasted with the CPU, right, which can be utilized for something else, right? So that is the reason the fifth point says it is expensive. Process to process communication is expensive. Sixth point. Now this is a very important point, guys. The process cannot take the advantage that when the CPU is idle, it cannot access the CPU when it is idle, right? It does not take the advantage. Whenever the CPU is idle, it does not say that, okay, CPU is idle, I can go and execute. It does not do that. Processes do not do that. Okay, that cannot take the advantage whenever the CPU is idle. Seventh point, it is comparatively heavyweight. That means I already told you it requires more amount of memory, right? So normally it requires more space, right, to execute that particular process. Next, it has a slower data rate multitasking. Yes, obviously whenever you want to multitask, the rate of execution, how fast it executes, is very, very slow compared to something called as thread based multitasking. So we'll move on to something called as thread based multitasking. Stay with me, guys. All right, so you can see here, we will see now what is thread based multitasking. Just now we have already talked about something called as process based multitasking. Now we're going to talk about something called as thread based multitasking. Now what is a thread, we will see in the next slide, but just remember, a thread is nothing but a lightweight sub process. What it means I will tell you a little later. Now what it basically means is, whenever you write a program, especially for example you write a C program or a C++ program or a Java program, it has a collection of functions. Normally whenever you run a normal program, sequentially it will run a function, one particular function at a time on the processor. Okay, so if it is running in one particular function, it will execute that function completely and then it will go to some other function. This is a sequential execution which happens with a normal program. But when you talk about a thread-based multitasking program, that means that if there are 10 functions, right, or let's say 4 functions are there in a program, 4 functions can be divided into 4 different threads, and each function can run parallelly on different cores of your processor. That is the advantage. In a single program, the single program is divided into multiple threads. That means each function will have a thread of its own, okay, and it will run parallelly on your processor. It is fast. So we'll see the different advantages of thread-based multitasking. So we'll see the first point. A thread-based multitasking is 2 or more threads can be run concurrently. Here we are talking about threads, not processes. Processes is nothing but a complete collection of all functions together. But when you talk about a thread, it's a single function normally, right? Next, second point, in thread-based multitasking, a thread is the smallest unit. In previous slide we saw a process is the smallest unit for a process-based multitasking. In this case, it is thread, which is the smallest unit. Okay. Next, third point, thread is a smaller unit compared to your process or a program. Thread-based multitasking requires less overhead. Okay, because remember your program is divided into smaller chunks or smaller pieces. Okay. Next, threads share same address space. So in a single address space, you can have multiple threads. All the threads can share a single address space. That's a very big advantage, guys. Next, we have thread to thread communication, right? If 2 threads want to communicate with each other, it is less expensive. It is much faster, guys, compared to your process based communication, process to process communication. I will just move my video to the top. Just a second, guys. All right. So the 7th point, it allows taking gain of the access of whenever the CPU is idle. Remember, I told you in the previous slide that a process cannot, or process do not take the advantage when CPU is idle. The process does not go and start executing in the CPU, but thread is much more smarter, where when it sees that CPU is idle, it can take advantage and go and execute on that CPU, right? So it does take the advantage whenever the CPU is idle, the thread will start executing on the CPU. That is a very important point, very big difference between a process based multitasking and thread based multitasking. 8th point, comparatively it is lightweight. Okay, because I already told you, your program or a complete program is divided into smaller pieces. It has a faster data rate multitasking. You can multitask it much faster. Again, it is just because of the functions, separate functions that you are executing parallelly or concurrently on the different cores of your processor. Okay, so next we'll continue with what is a thread. Okay, so I will see you in the next slide. All right, so next we're going to look at something called as Java thread model. Okay, now what is a Java thread? Java thread or a thread is nothing but a lightweight sub-process. That means, that name itself tells you sub-process. Sub-process means out of the complete program which has a collection of functions, it is each function that you are talking about. Okay, so for example, you have 10 functions in a program. Function 1 is a sub-process, function 2 is a sub-process, function 3 and so on till function 10. Each function is called as a sub-process. Right? In Java, you would have already seen that every time you execute a program, your main function is the function which gets executed first. Okay, so main function, from main function, you will call the other functions. Right? So remember, from main function, whenever you go, the main function in Java is called as a main thread. Okay, a name given to a main function in Java threads is called as main thread. From main thread, it will call all the other sub threads. Okay, so from main function I am calling other functions, that means it is calling the sub threads, other threads, right? So remember, multiple functions, okay, in the same program are running parallelly or concurrently on the processor. That is the main idea here, right? In Java's multi-threading model, one thread can be paused without stopping the other parts of the program. Now this is a very important thing. Okay, so a particular thread can be paused, right? The other threads can still continue to execute. That is possible only with multi-threading technology. If any thread is paused or blocked, still the other threads can continue to run. Next, the threads can be in any of the 5 different states, guys. There are 5 main states for your threads, okay, or 6 you can take it as, right? One is called as ready to run. That means right when that particular thread gets the CPU time, then it is normally called as, it is in ready to run state, or it is called as new state. Next, it can be in running state. That means if the thread is actually executing on the processor, then it is said to be in running state. Next, we have something called as suspended. Now when you talk about suspended, normally it happens whenever, for example, that thread needs some resource. Okay, if it is waiting for some resource, for example, an input from the user, right, or maybe some input output operations that needs to occur with some device. In that case, that thread will be suspended. Okay, so suspended means it is not completely, stopped executing. It is waiting for something to happen. It is temporarily out of service, or it is not working temporarily, right? Next, we can also have something called as block state. Now block state is mainly used for whenever it is waiting for some resources. So when the thread is waiting for some resource, it is in something called as blocked state. Next, after it is either suspended or blocked, it can again resume the execution of your thread. Just one second, I'll move my video, guys. Alright, so you can see here, a resume state basically means that if that thread which had been suspended, okay, temporarily, because of maybe some input from the user, or it is in block state because it is waiting for some resource, then it can still start executing from where it left off. Okay, that state is called as a resumed state, or suspended thread resumed and start from where it left off. Finally, we also have something called as terminated state. Now terminated state is nothing but a state where obviously your thread will be it will be removed from that particular processor. Your thread will stop executing in that processor. All the memory, all the resources will be deallocated and the thread will exit the processor. Right? So these are the 6 different states you can have. Make sure you know this. This is a very important topic for your interviews, guys. thread topic is a very important topic, because for me, when I went for my interview at Dell in Bangalore, I got questions from this Java thread itself, right? So it's a very important thing, because most of the programs nowadays are written using this thread concept. So normally they will ask you some questions on this Java thread as a fresher. So make sure you know these things. So these are the 6 states. Remember that: a new state, running, suspended, blocked, resumed, or terminated. So these are the 6 different states that a thread can be in. So we'll move on to the next topic, guys. All right, we're going to see a small diagram now of a Java thread model. So you can see here, guys. I hope you are able to see it. Now in this case, there is something called as a new state we have looked at. Now in this diagram he has shown new state and ready to run state separately, but they are all same, right? So whenever it is about to get the time slice or the time for the CPU for the execution, then normally it is called as a new state or ready to run state. That means it has got the time, it is about to get the time, and it is ready to run on the processor. Now as soon as it goes into ready to run, then obviously it can go into running state. Running state is nothing but when that thread starts executing on the processor. Okay, from running state, I told you it can go into something called as waiting state, or nothing but your block state, or it can be waiting for some resource, right, or suspended state, right? These are the different states you can have. You can see in that diagram it can go into sleeping, waiting for some notification, block for join completion, or block for IO, right? So these are the different reasons why it can go into something called as blocked state or suspended state. From there it can again come back and go into the ready to run state, where it is again starting to resume, or it is also called as resume state, right? So finally after the execution is over, it will directly go to the termination or the dead state, guys. Okay, so we'll continue with something called as thread priorities now. Alright, so we're going to look at something called as thread priorities, guys. What do you mean by thread priorities? Now remember, I just now told you in the previous slides that you can have multiple threads running parallelly at the same time, right? Now you can also have priorities for the threads. You can say that out of 10 threads, there are maybe, for example, in a processor there are 4 cores. So parallelly you can have only 4 threads running parallelly at the same time. The other threads have to wait, right? So in that case, you can prioritize your threads. By default, normally your priorities of a thread is from number 1 to 10. 1 being the lowest priority, 10 being the highest priority. Okay, so and normally by default, whenever you create a thread, I'll show you that in another video of how to create a thread, and we'll see a program on that also, right? But when you create a thread, new thread, by default the priority given for your thread is 5. By default it is always 5, guys, the priority. Okay, so it is neither 1 or 10, it is in between, exactly in between, that is 5. All your threads by default, if you do not specify the priority while creating the thread, will be by default 5, right? Next, why do we need a thread priority? The reason is because you have many threads that want to run on the processor, okay, but the cores are not enough. Then you have to prioritize which thread will get the processor time. So in this case, whenever a thread switches from one thread switches from itself to another thread, then it is called as context switching. Now this same concept you would have come across in something called as operating systems. Same thing is here, guys. So whenever a thread switches from itself to another thread, then the time between the switching is called as context switching. Okay, so you can see there on the screen, it says that a thread's priority is used to decide when to switch from one running thread to another. This is called as context switching. There are 2 ways of how context switching can occur. There are 2 main rules. Okay, these are very important rules, so listen carefully. One rule is a thread can voluntarily relinquish its control. That means a thread which is running on the processor says, okay, I am done, please you can come and execute. It will say to the other thread, I have been running for this long, so I will go out of this processor, you can come and start executing on the processor. Okay, that is one way of context switching from one thread to another thread. Another way or another rule of a thread switching from one to another is a thread can be preempted by a higher priority thread. Now this is where the priority is coming to picture, guys. So for example, if a thread has been given a priority of maybe 4 and another thread which is waiting in line and it has a priority of maybe 8, 8 having a higher priority, 4 having a lower priority. So what happens? It will check, okay, there are two threads, one is running, that is the priority with 4 is running on the processor, but there is a thread with a priority 8 which is waiting. Then what happens? The processor will basically switch between your lower priority to higher priority thread, and the higher priority thread starts executing on the processor. Okay, always the higher priority thread will always get the processor ahead of the lower priority processor. Lower priority thread, right? So that is the second point. Preempting means basically telling that you can basically it will stop, right, abnormally. Basically, if a higher priority thread comes, the lower priority thread just comes out of the processor and the higher priority thread just gets the processor time. So this is how it happens, guys. So these are the two main rules that can have that occur whenever we talk about thread priorities. That is, one is a thread can voluntarily say relinquish the control of the processor, or the second is a thread can be preempted by a higher priority thread, right? Now there might be a question for all of you. What if two threads, that is you have created maybe only two threads in your program, both are having a priority of 5, right? Now in that case what happens? Or for example, you have maybe four functions or 5 functions you have. All 5 functions are having the same priority. Your processor has 4 cores. So each core there is each core there is a thread running, that is 4 threads are running, 1 thread is waiting. That thread is also having a priority of 5. Then what? Which thread will get the access? So in that case, it is little more complicated. There are different algorithms which are used. Normally you would have learnt in operating systems, right? There are different algorithms that can be used. Now normally in Windows it uses something called as round robin, right? Round robin is nothing but after it executes, right, a thread basically gets the execution time in the processor. It will exit. The thread which is waiting again will get the processor time. So in the round robin fashion it keeps on executing, right? So there will be a small slice of time given to each thread. So for example, if thread time slice is 2, for example, for 5 threads, each thread will execute for 2 seconds in that processor. Again it will wait in the line, again it will get the process time for 2 seconds, and so on, right? This is how the round robin algorithm works, and that is what Windows normally uses, right? So different operating systems have different strategies of how to make the threads get the access to the processor. Okay, so I hope you have enjoyed this video. I hope you have understood what I have told you. Very important concept about threads. Please go through it once more if you need to. Please go through the life cycle of a thread, the states of a thread. Look at that diagram we have gone through, thread priorities. Okay, and then make sure you know the difference between a process based thread and a process based multitasking and a thread based multitasking. Okay, so thank you for watching, guys. I will come back with another video on basically writing a program on thread, how to create threads and all. So I hope you have enjoyed it. Please share this video with as many people as you can. Like the video, and I will see you in another video, guys. Thank you.